Hello YouTubers, welcome to this very simple video where we will demonstrate how we test PN junction diodes. As I have in my hand right here is a PN junction diode. As you can see, there's a part that is filled with black and there's a part where there is a little stripe. This particular model is 1N4001. That's the one we will be working with today. Now a diode, as some of you may know, is a simple semiconductor component that allows current to flow in only one direction while blocking current to flow through the other direction. Now if we look closely at this diode, the part with the mark is called the cathode, while the part where there is the majority of black is called the anode. In essence, the cathode is negative while the anode is positive. Now if you look down at this paper here, we can see we have a 1N4001, and one part is anode, the other part is cathode. And basically in this other drawing, what we can see is I have drawn sort of a valve that would demonstrate the action inside of the diode. So basically what will happen, in order for this to work, you bias it forward bias. Forward bias simply means applying an external source or connecting an external source to this PN junction. So a voltage applied to this part will cause this valve to open or to burst, and therefore allow current to flow through the diode. And then you will have a diode that is forward bias. If you were to apply a voltage from this side and try to feed the voltage or feed current from this side, this valve will prevent it, because this valve, if you look at it as it is, this valve will remain closed or will always be closed unless or until a voltage is applied to it, and a voltage that is strong enough to cause it to open. The voltage that will be strong enough to open it would be generally most silicon diodes, and they vary with different diodes, Zener and Schottky diodes and so on. They vary, but it would be from 0.4 volts to 0.8 volts, which is normally referred to as a VD, or a voltage drop. A voltage drop of 0.4 volts to 0.8 volts. A voltage drop is basically the voltage that will be used by this diode in order for it to work. So you basically would have this voltage being lost. If you were to feed current through this side, this valve will be closed, because this valve will remain closed unless a voltage is applied to that side. Feeding it there, it will be closed, and unless in some extreme cases where you put your diode in reverse bias and expose it to extremely high voltages, it will damage this, cause this diode to go into avalanche breakdown. And you know, avalanche, when it comes down from the mountain, it can't go back up. So this, what you have is a shorted diode, a damaged diode, a diode that is no good. Now as we go, in other parts, like for example a xenodiode, when we get into that, you will see the difference from a xenodiode from this diode. So basically that's that should do it for the theoretical aspect. Generally, basically, that's what you need to understand. The diode allows current to flow in one direction but prevents it from coming back the other direction, and therefore AC will not be able to work with it. In fact, it will change the AC to one direction current, or in other words DC current. So we will now go into testing it using a multimeter and see how you know if a diode is good or not. So now it's time for us to test. I have here same diode 1N4001, and we will now demonstrate how to test it. Again, as we were saying, we must apply, it will allow current to pass through one direction but not the other. This red probe of my multimeter will act as the current source. It will push the current or the voltage, apply it to the one part of the diode, and we expect it to get a read a voltage drop across the diode. Now we will turn our multimeter to the diode test range. I have a Mastec MS8268. So this area, this section, will measure continuity or diode, but you would have to press the select button to get there. So we'll keep it on the diode check. This part of this is the anode of the diode, and this is the cathode. The positive probe will act as the source where we push current, and the black will be placed on the cathode. Negative to negative, positive to positive, and you're supposed to get a reading. So let's see. Okay, as we can see, we are reading on our meter. 0.449. Check it again, 0.449. That would round off to 0.5. So it's still well within the range. So this diode is good. Let us just demonstrate if we were to switch the leads over and put the positive to the cathode and the negative to the anode. Just notice that we get in over limits or overload. Alright, so we are not getting any reading. There's too much resistance, so no current is passing through this direction. Once again, let's turn it back this way, and as we can see, it is good. So thank you very much for watching. If you like the video, please give it a thumbs up, and if you would like to receive more videos as I continue to produce them, you could subscribe to the channel and share it, Facebook also. That would be very, very nice of you. Thank you very much, and if you have any comments, suggestions, and so on, please put it in the comments below. Thank you very much.